All right, ladies and gentlemen, for our next adventure, we're going to start talking about molecular formula. These molecular formulas, let me move this out the way. These molecular formulas here are more specific actual whole number ratios of atoms within a compound. So we're taking the predictive step of empirical formulas and we're adding another detail to it per se. So these are multiples of empirical formulas because you need your empirical formula to get to this molecular formula. So you got to be careful. We're talking about formulas here. So just like the empirical formula steps, we are not paying attention to diatoms because these are in formulas, okay? That's the only reason we're not paying attention to these diatoms here. They are formulas, so that means they are bonded together. So when we're talking about these molecular formulas, you have a 4-step rule to success. So first things first, you got to find the empirical formulas. That's the stuff we did last section. Where percent to grams, grams to moles, divide by the smallest and round to the whole. That part. So step 2 is you got to determine your molar mass of the empirical formula. So we're going to throw that together. And then you take that and you divide the molar mass by your given. So you have to pay attention to what the problem's giving you. Take the gifts you're given. Once you divide what you calculate versus what you're given, this gives you your multiple on what to multiply everything by. Once you get your multiple, you just throw it in there. So let's walk through a couple steps. Some examples. It sounds easy in process, but once we start getting into it, things might get a little messy. So here we go. For our first examples, we're going to find the molecular formula. Okay, I know I got some steps to follow. That's up here. Then we got to find the molecular formula for a compound made up of 40% carbon, 6.7% hydrogen, and 53.5% oxygen if the molecular mass is given to me as 60 grams per mole. All right, so step 1, I got to find the empirical formulas. So to find your empirical formulas, you're talking about your, let me get my thing back here, percent to grams as your first step. In your empirical formulas, we go percent to grams, then grams to mole, okay? That's exactly how we're gonna do that here. So we pull out our handy dandy calculator. I've done the first couple for us, save us some time here. So 53.5 divided that by that molar mass of 16 gives us a whopping 3.34375. All right. So percent to grams, grams to moles, and then we're gonna go divide by the smallest. So I'm gonna take a look here and see which one's the smallest, and we get a whopping winner, winner, chicken dinner here. So we're gonna divide by the smallest. Real quick, blah, blah, blah. We know I gotta keep all of those numbers here to make sure my answers are consistent. Capiche? So I gotta make sure my answers are consistent here. I'm gonna slide this over so we can see things a little bit better. All right, so let's get it cracking. I'm gonna recall some stuff down here for myself. So I need 6.46 divided by that 3.33. Oh, no. Oh, no. Haha. Let me just do it this way. I'm over here being difficult. So I got... Da-da-da-da-da. There we go. So then I got 6.7 divided by All I'm doing right now is getting those molar values back in my calculator for ease of use here by dividing by that molar mass. So then again, we're gonna see who's our smallest, and by 100th, we're breaking a tie between that first and that last one. So we know the first one divided by the first one is 1. So something divided by itself is 1. All right, so we're gonna take we're gonna see if I can't grab it here. That divided by the smallest, and just slide up and get the numbers from the calculator instead of having to type them all in. That rounds to nice and pretty to a 2. I don't have to double anything. And we're gonna take that last value here divided by, I should get something pretty close to 1. All right, so I have an empirical formula. An empirical formula of what? Carbon, hydrogen is 2, and oxygen, so CH2O. That is my empirical formula because I don't have anything when I have round to the whole. I don't have to fall into any of those weird doubling categories, so I'm done, right? So step 1, find the empirical formula, I've done. Now step 2. Step 2, in my notes, I need to determine the molar mass. And I'm gonna abbreviate that MM of the empirical formula. All right, light work. We've been doing this for a hot second. So this should be nothing new to us. Let's determine that molar mass real quick. So here I got CHO. I got 1 carbon, 2 hydrogens, and 1 oxygen. And I'm gonna pull those mass values off of my periodic table here. All right, easy breezy, beautiful. Nothing too crazy just yet, so I'm gonna just multiply across. 1.008 times 2 here gives me the 2.016. 1 times 16.00 is 16. And then once I multiply across, I'm gonna add them up down. So here, 12.01 plus 2.016 plus 16.00 gives me a whopping 30.026. Now, if doing things stepwise like this isn't your jam and you need to save yourself a couple seconds on the computation skills, parentheses are your friends here. So if in parentheses I do my multiplication, do my addition on the outside like I'm supposed to, 2 times 0.1008, you see how I'm setting it up here where I have my multiplications that are happening right here inside a parentheses set, and then I'm adding in between like I normally do here stepwise. I'm doing everything all at once, so if you need to find yourself saving some calculator steps, you should get the same exact answer here, and in fact, we do. So that's just a little tip and trick on how to help you cut off some time while you're doing these. So let's move it along. I've got my molar mass, so let's move back up to our steps. So step 3, I've got to divide the molecular formula molar mass. This is what I calculate. Divide that molar mass, which you've calculated, by what you're given. Capiche? By what you're given. So let's see, I calculated 30.026 is a calculated value. I'm gonna remind myself that's my calculated molar mass. And what's the gift that was given to me? I was given 60.0 grams per mole as a given value. I need to take given by the empirical mass you calculate. So given over calculated. All right, easy breezy, beautiful. 60 here, divided by my calculated, gives me a certain multiple that I get to use. That multiple is, if my mental math is right, something close to 2.026 here. Oh no, 60 divided by 30.026. All right, 1.99826. 81676. All right. 1.9998. That's really close to 2, so I'm going to go ahead and cut that to 2. So I'm multiplying everything by 2 here. So this is my ratio. That's my ratio that I've got to put into my empirical formula I've calculated up here. So if you get your empirical formula wrong, the rest of these steps are null and void. Capiche? So it is imperative you are comfortable and confident in calculating those empirical formulas. So I'm going to drag down that empirical formula here. CH2O. I found my multiple of 2, so I'm going to raise everything times 2. So that will go to that carbon, to that hydrogen right there, and to that oxygen right there, leaving me with C2H4O2. That is a molecular formula. All right. Easy, breezy, beautiful. So you got to make sure you're really confident in those empirical formula skills, and then you're adding some more details to that. So you're just taking what's given to you, divided by what you've calculated, and then sending that through your entire empirical formula here. Let's work it again. So a compound is 54.5 grams of carbon, 9.1 grams of hydrogen, and 36.4 grams of oxygen. The molecular mass of this said compound is 220 grams per mole. Find the molecular formula. All right, so off the jump, I know step 1, I need to find an empirical formula. Easy breezy, beautiful. Grams, percent is grams, grams to moles. I don't have any percents, so I go straight from grams to moles. 5.5 grams of carbon. I'm gonna just make my list here. And start turning into moles with that one-step stoichiometry we know. And give myself some more room here. There we go. I like that better. All right. Now we all know what goes down here, but I'm gonna give us a second to find it on our periodic tables. These again are those molar mass values. Those are our molar mass values. They're the same. All right. We gotta do our division to get ourselves, no? Aha, back into moles. So 54.5 divided by 12.01. Oh, that is ugly. Try that again. 4.5. 37.8850958. A crap ton of 7s. There we go. I think that might be an extra 7. 36.4 divided by 16. 2.275. All right. Find that. Divide by the smallest. The smallest would be. Give you a second to figure it out. Winner, winner, chicken dinner. So I'm pretty far into my molecular formula calculations here. So let's make sure I ain't got to do no weirdo doubling. So I need that one divided by Datin. 3.96825, blah, blah, blah. Enter, divided by, this is how I quickly keep all of the decimals, so that keeps me from having to keep typing into the calculator so much. So use your resources, friends. All right, looking at this, I don't have anything I got to double here, so that's 3.96, that rounds to approximately 4. And 1.99 rounds to that 2. So my empirical formula down here comes to C2H4O. That's my empirical formula. I'm not done yet, so I gotta find my empirical formula, which I have moved, calculator, thank you. So right now I have found my empirical formula. Now I gotta determine the mass of my empirical formula, so let's get me on down here and go to work on determining that mass, which by now we can do in our sleep, hopefully. I done sat here and wrote it all twice. Ooh, Heavenly Father. More caffeine is needed. All right. Get that 2 times 12.01. Here's me doing that shortcut I just talked to you about. If you so choose to, when you have access to this kind of calculator, you can save yourself a few steps. But the other way works just fine. We all come to the same answer. And look, I'll prove it to you. 24.02 plus 4.032 plus 16. See? Easy breezy, beautiful. Don't stress yourself out about needing to have a scientific calculator. My calculators will do the stepwise things just fine. Now I take what's calculated. I drew it out real nice up here. What's given divided by what's calculated, okay? Given by calculated. That's what you want to divide. Given by calculated. And in this formula, I am given a gift of 220 grams per mole. Divided by, we calculate 44.052 grams per mole for that molar mass value. So let's see what we're working with here. 44.052. Dun, 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 dun. Let me move that out the way over here. This gets me 4.9940978843. Round that up to 5 because we can't have partial ratios. All right, they're always whole number ratios. So we're going to send that through our entire empirical formula. So I'm going to bring that down, C2H4O, and and get my ratio, I brought it down. And that ratio of 5 will go to this O, it'll go to 4, and go to that 2 from carbon. So what we will end up with is C10, H20, because 5 times 4 is 20, and O5. That is our molecular formula. Easy breezy beautiful. That's the down and dirty of molecular formulas. Questions, comments, concerns, you can send me an email. I'm happy to help where I can, but to overview really quickly, these are just the same process as finding empirical formulas. You're just adding more details along the way. You're seeing your original whole number ratio of atoms and compounds. Remember that empirical formula is that representative model of the ratio of numbers. This is that more precise. So empirical and formulas are more general. Empirical formulas are more general. Molecular formulas are more specific, but however, they can be the same. They can be the same. So don't let that get you tripped up. They can be the same. It's just this one's a little more specific. And to find that, you got to determine your molar mass of the empirical formula and divide what's given by what you calculate, and then send that ratio through your entire empirical formula. So here we're doing step 1 of finding an empirical formula, percent to grams, check, grams to moles. We've done that. Divide by the smallest, round to the whole. That's what that mess is here, and we found our empirical formula. Once we find that, get that mass value here. Then after you get your mass value, you take what's given divided by what's calculated. That gives me my ratio of 2. I send that 2 to my entire compound, giving me my molecular formula. So questions, comments, concerns, you can always send me an email.